Welcome to Chemistry Online. Today we're going to talk about Lewis dot structures. Let's go back and think about carbon. We talked about carbon previously. We said that carbon-12 has 6 neutrons, 6 protons, and 6 electrons. The electron distribution is between the first and the second quantum level, 2 electrons in the 1s, and 4 electrons, 2 in the 2s, and 2 in the 2p. The electrons in the first quantum level we call core electrons. They're there, but they're not involved in the formation of chemical bonds. The electrons in the highest energy levels, however, are the ones that we use for bonding. These are called the valence electrons. For carbon, we have 4 electrons in our valence shell. The Lewis dot structure is a device developed by Lewis many years ago to help explain chemical bonding. In a Lewis dot structure, you start off with the symbol for your atom. Here we have carbon. Carbon is in group 4a. That means it has 4 valence electrons. Again, we don't care about the core, just the valence electrons. In a Lewis structure, we show these as dots placed around the element symbol. The rule for placing the electrons around the symbol is that they go in one at a time until we have 4. After we get 4, we start to pair them up. For example here, if we were going to do fluorine, as we see, is in group 7. It has 7 valence electrons. We start off placing 4 around it, and then we pair them like this. Now remember that a Lewis dot structure is just a bookkeeping tool. It doesn't matter where we put our paired electron, top, bottom, side, whatever, just that once we have 4 electrons, we start to pair them up. If you look at your periodic table and you look at the groups 1a through 8a, they describe very nicely the number of valence electrons. Here we have group 1, hydrogen, all the way to group 4, silicon. And this continues over here till we get to our group 8. In our group 8, our inert gases, we have a complete valence shell, that is 8 valence electrons. Now we can use a Lewis structure to show ions. If we have an unequal number of electrons and protons in an atom, the atom is charged, is called an ion. Positive is a cation, negative is an anion. In a Lewis structure, you simply draw your Lewis structure, add or subtract electrons to give your final charge. Again, for example, we're dealing here with chlorine. Chlorine is group 7. We start off with 7 valence electrons. To make our chloride anion, we add 1 more. And we wind up with this. This is the same configuration as the inert gas argon. Let's do a problem. Take the sulfide dianion and let's draw its Lewis structure. We start off with sulfur. Sulfur is here in group 6, so we have 6 valence electrons. To make the dianion, we add 2 more electrons, and it looks like this. Nitride trianion. Well, nitrogen is here in group 5. To make the trianion, we simply add 3 electrons. And finally, sodium. Sodium is here in group 1. That means we have 1 valence electron. To make the sodium cation, we simply have to lose that electron, and we're left with a positive charge. Now let's think what we've done in all these cases. What we've done is to take our atom and we've added or subtracted electrons until we reach the configuration of one of the inert gases. This is called the octet rule. For chlorine, we started in group 7, we added 1 electron, and that gave us the configuration of argon. For sulfur, we started in group 6, we added 2 electrons, again, we're at argon. For sodium, we started in group 1, we lost 1 electron, we are now 1 period above with the configuration of neon. Once we have the configuration of the inert gas, the ion is very stable, and that's why this is referred to as the octet rule. Now we can also use Lewis structures to draw covalent bonds. Molecular chlorine exists as Cl2. In order to show a covalent bond in a Lewis structure, you simply start with the atom you're dealing with. Here we're going to move another chlorine up. The electrons that you share between the atoms are counted for each atom. So for chlorine here we have 8 electrons. For this chlorine we also have 8 electrons, counting the shared ones for each atom. Often when you draw Lewis structures, you'll replace the electrons here with a simple dash. The dash makes it easier to draw. Whenever you see a dash like this, remember this represents 2 electrons in a covalent bond. Let's do a simple problem. Take ammonia and let's draw its Lewis structure. We need to find our atoms, we need to arrange them, nitrogen in the middle, and we're going to move them together to form covalent bonds. Nitrogen is group 5, hydrogen is group 1. If we take and we move these together, we get something like this. Again, our nitrogen now has a full octet of electrons, and each hydrogen has a configuration of helium that is 2 valence electrons. We could draw this using line bond this way, and again this is referred to as a simple single covalent bond. Molecular nitrogen. Well, nitrogen is in group 5. We have 2 of them. I'm going to put them next to each other in order to form bonds between our 2 nitrogen atoms. We can form one bond with these 2 electrons, no problem, but that would give us 1, 2, 3, 4, 5, 6 electrons around the nitrogen. What we're going to have to do is to take these extra electrons, these unpaired electrons, and simply move them in so that they're paired between. Here we've moved this pair from the bottom up. We now have 1, 2, 3, 4, 5, 6, 7 electrons around each nitrogen. Doing it again, we have 8 valence electrons around each nitrogen. And we could show this in line bond this way, where we have a nitrogen-nitrogen triple bond.